And welcome to this SKC training event. I am Debbie Dietrich, the Corporate Industrial Hygienist for SKC, and I am pleased to present this webinar on size-selective sampling of particulate matter. This webinar will focus on particulate sampling for occupational hygiene applications. SKC does, however, offer products for environmental sampling of particulates as well. Airborne particles include a variety of solid and liquid matter defined in this slide. Although the term dust is used generally to describe particulate matter, technically, dust is defined as solid particles generated during actions like crushing of rock-like material. Fumes are microscopic particles generated during welding and similar operations. Despite what we hear every winter on TV news reports, people are not overcome with carbon monoxide fumes. Carbon monoxide is a gas. Mist are liquid droplets, and smokes are particles generated from incomplete combustion. As a point of clarification, please note that I will use the term dust to describe particulates in general. So when you hear me say dust in this webinar, I am not referring to the strict technical definition of dust given in the previous slide. Also note that asbestos and other fibers are also hazardous particulates found in the workplace. But I will not discuss fibers in this training module since size-selective sampling of fibers is not done. Health effects of airborne particles are determined by three parameters. First, the chemical composition. What is the chemical makeup of the particulate matter? Secondly, mass concentration. How much is being inhaled by exposed individuals? And finally, size characteristics. How big are the individual airborne particles? Particle size is a very important factor in determining where particles will deposit in the respiratory system. Smaller particles are of critical concern since they will deposit in the lower regions of the lung and can enter the bloodstream. Because particle size plays such an important role in the health effects, government regulations and exposure guidelines are issued for some compounds based on their particle size. These so-called size-selective exposure limits specify different allowable levels for smaller versus larger particles of the same material. Let's now look at how particulates in the occupational environment are defined and measured. We'll start with the older traditional definitions and samplers. Traditionally, particulates have been defined as either total or respirable dust. Total dust is collected using a designated filter that is loaded into a 37mm cassette. Using typical flow rates of 1 to 2 liters per minute, a pump is used to draw air through the filter for sample collection. This technique is used for personal or fixed point area samples. Here you can see the schematic of a traditional 37mm filter cassette loaded with a filter. The inlet of the filter is typically pointing down during sample collection. In this way, the collected dust represents what the pump actually pulled into the filter cassette and not what just lands onto the filter due to gravity or due to impaction from activities in the workplace. A reference method for total dust sampling is NIOSH method 0500, entitled particulates not otherwise regulated total. In this method, a cassette loaded with a PVC filter is placed into the breathing zone for sample collection and then is analyzed gravimetrically. Like with total dust, respirable dust is also collected onto filters to evaluate exposure levels. Preceding the filter, however, is a size-selective sampler that will separate the smaller respirable fraction from the larger non-respirable fraction. Cyclones have been traditionally used for size selection of respirable dust, but impactors are now available from SKC for respirable dust sampling as well. A primary method for respirable dust sampling is NIOSH method 0600, entitled Particulates Not Otherwise Regulated Respirable. This method lists 3 cyclones as options for separating the respirable from the non-respirable fraction. The SKC aluminum cyclone at 2.5 liters per minute is one of the options listed in this NIOSH method. After passing through the cyclone, respirable dust is collected onto PVC filters for analysis. Cyclones function on the same principle as a centrifuge. When the air comes in through the small slit opening on the side, cyclonic action occurs within the stem of the sampler. Large non-respirable particles are thrown out by centrifugal force, hit the side of the cyclone, and fall into the cap of the grit pot at the bottom and are discarded. Smaller respirable particles are thrown upwards onto the filter and are analyzed. Now let's discuss new issues in defining and measuring workplace particulates. Specifically, we will address new sampling concerns, new definitions for particulate size fractions, and new size-selective samplers. A concern that U.S. NIOSH and OSHA have been addressing recently is sample loss with traditional 37mm filter cassettes. This sample loss is the result of particles that stick to the side of the cassette and are never analyzed. In the latest version of the OSHA method for hexavalent chromium, OSHA points out that more hexchrome can sometimes be found on the side of a cassette than on the filter itself. So to address this concern, it is now a routine procedure for OSHA to not just rinse, but to also wipe the walls of the cassette for all metal samples analyzed. NIOSH reported similar findings in a September 2007 journal article, and they concur with OSHA's directive to wipe the inside of the cassette walls for analysis. As an alternative to wiping cassettes, a sampler called the AccuCap has emerged to solve the problem of cassette wall losses. The AccuCap is simply a filter insert that is placed into a 2-piece cassette with support pad for use. The AccuCap consists of a clear plastic dome that is heat sealed to a PVC filter. Dust is collected onto the filter or within the dome for gravimetric analysis. In 2013, another new sampler emerged based on the AccuCap design. The new sampler, called the SoluCap, is designed for measurement of metals using chemical analysis. The SoluCap has a dome material that allows for acid digestion by the laboratory and analysis using standard methods. The dome is heat sealed to a mixed cellulose ester filter for sample collection. Like the AccuCap, the SoluCap eliminates the need to wipe the inside of the cassette for analysis and ensures all collected sample is analyzed. Another recent issue is how occupational hygienists define particulate size fractions. Many occupational hygiene agencies and standard setting bodies around the world have abandoned the two size fractions of total and respirable and have instead defined three particulate size fractions. Particulates are now often defined in terms of inhalable thoracic and respirable particulate mass. Note that in the U.S., OSHA and MSHA have not officially adopted these new size fractions, but ACGIH does indeed use these new definitions for their threshold limit values, or TLVs. Here you can see an illustration of the three new particulate fractions. Inhalable particulate is material that is hazardous when deposited anywhere in the respiratory system, including the nose and mouth. Thoracic particulate is hazardous material deposited within the lung airways and down to the gas exchange region of the lungs. Respirable particulate is that deposited within the gas exchange region. When doing size-selective sampling, you will frequently see the term 50% or median cut point is used to describe the performance of sampling devices like cyclones. It is important that you understand this term. Sampling devices are not 100% efficient in collecting all sizes of particles, from microscopic fumes to large dust. The particle size that the sampling device collects with 50% efficiency is described as the 50% or the median cut point. To help understand 50% cut point, consider the performance of a common vacuum cleaner. Vacuum cleaners do not pick up all sizes of particles with the same efficiency. A vacuum cleaner may be 100% efficient in picking up a small piece of lint. It may be 0% effective in picking up a bigger stone. But there is a size where the vacuum cleaner is 50% efficient in picking up. The same is true for a size-selective air sampler. Note that a size-selective sampler will always have the 50% cut point specified for a designated flow rate. That flow rate is critical. Particles smaller than the 50% cut point will be collected with an efficiency greater than 50%. Larger particles less than 50%. Let's next review the new particulate size fraction called inhalable particulate mass. Inhalable particulate is essentially the new total dust. It is defined as dust that is hazardous when deposited anywhere in the respiratory system, including the nose and mouth. It is collected using a sampler designed and tested to capture this size of particulate matter. Note that inhalable samplers have a 50% cut point of 100 micron. The very first sampler designed to meet the new criteria for inhalable dust was developed at the Institute of Occupational Medicine in Scotland and is named the IOM sampler. The IOM sampler was licensed for manufacture by SKC Limited in the UK, and it is the gold standard for inhalable sampling. The IOM is specified by name in many international standards and published methods. To use the IOM sampler for gravimetric analysis, first, load a 25 millimeter filter into the cassette. Then equilibrate the filter cassette overnight under controlled conditions of temperature and humidity and weigh them as a unit. Do not desiccate the cassette filter assembly. Collect the sample at 2 liters a minute. And then, after sampling, equilibrate and weigh again following the same procedures for analysis. The IOM offers users the advantage of no sample loss. Since the filter and cassette are weighed together, all particles which enter through the sampling inlet are part of the analysis. Any particulate dislodged from the filter will be retained inside the cassette and weighed. For chemical analysis of metals and other compounds, the IOM with the stainless steel cassette is frequently used. The stainless steel cassette is often preferred since the lab may rinse the cassette with chemical solvents for chemical analysis. In the European hygiene community, there is a great interest in the use of polyurethane foams for size-selective sampling of particulates. In recent years, the UK Health and Safety Laboratory developed polyurethane foam discs that are inserted into the IOM cassette for simultaneous sampling of inhalable and respirable dust. Note, the dust on the filter only is the respirable fraction. The dust on the filter plus the dust in the foam is the inhalable fraction. So in summary, there are 3 models of IOM samplers from SKC. The plastic sampler with a plastic cassette, typically used for gravimetric. The plastic sampler with a stainless steel cassette, typically used for chemical, but also used for gravimetric. We also have a stainless steel sampler with a stainless steel cassette. This is a specialty item normally used only for bioaerosol sampling or extreme static conditions. Since the development of the IOM sampler in 1986, other inhalable samplers have emerged. Shown here is a sampler developed by researchers at the University of Cincinnati called the button sampler. The inventors of this sampler have noted the advantages shown on the slide. First, the button sampler has a screen over the inlet to keep out non-inhalable particles that may become airborne during workplace activities. The button sampler also uses higher flow rates than the IOM, which helps in the measurement of compounds with very low exposure limits. Note that there is no cassette with the button sampler. The filter is placed directly onto a stainless steel support screen for sample collection. Note also that the button sampler has a flow rate of 4 liters per minute compared to 2 liters per minute for the IOM. So this enhances the sensitivity of measurement for compounds like beryllium with a very low inhalable TLV. There are two very important considerations when using the button sampler. First, you must use a filter with a pore size of 1 micron or larger. Otherwise, at the required flow of 4 liters per minute, your personal pump may fault with dust accumulation due to back pressure issues. Next, since there is no filter cassette, you will have to have a secure device to transport your filter sample to the lab. SKC offers filter transport cases or filter keepers for this purpose. It is generally preferable to use a calibration adapter to assist in flow measurement. SKC offers calibration adapters that allow the IOM and button samplers to be directly attached to external flow meters, such as the Defender primary standard. The next particulate size fraction that we will discuss is thoracic particulate matter. As discussed previously, the first bullet on the slide shows the definition of thoracic particulate. Note that thoracic samplers have a 50% cut point of 10 micron. And remember, the inhalable have a cut point of 100 micron. There are only 2 TLVs issued as thoracic particulate as of 2014, and they are sulfuric acid and cotton dust. At this time, there is only one NIOSH method excuse me, that specifies a thoracic particulate sampler. NIOSH method 5524 for metalworking fluids specifies sample collection using a 2-micron PTFE filter in a 37 millimeter cassette or an optional thoracic sampler. At the time the method was published, the only thoracic sampler available commercially was a cyclone from BGI Incorporated. Since the metalworking fluids method was published, SKC has developed a thoracic impactor. The SKC Parallel Particle Impactor, or PPI, was designed to give a precise match to the thoracic criteria and can be used with any suitable 37 millimeter filter at 2 liters per minute. Note that the SKC thoracic PPI is not specifically listed in the NIOSH method for metalworking fluids, since the PPI was developed after the method was published. SKC thoracic PPIs are available in reusable or disposable options. The reusable thoracic PPI is constructed from anodized aluminum, and the disposable PPI is constructed from conductive plastic. The disposable model eliminates the burdens of sampler assembly and cleaning and is available preloaded with filters for designated applications. Both the reusable and the disposable thoracic PPI samplers are designed for use at 2 liters a minute with analysis, following the same techniques as specified in methods using traditional filter cassettes. Here you can see a schematic of the PPI operation. The 4 inlets on the sampler are precisely sized so that the particulate matter collected onto the final filter is a very close match to the criteria. Here you can see the data generated by the SKC aerosol physicist for current thoracic samplers. Both the SKC thoracic PPI and the BGI thoracic cyclone give a close match to the international thoracic criteria. Next, let's examine respirable dust. Throughout the history of occupational air sampling, Several definitions of respirable particulate matter have been adopted by various organizations around the world. All definitions describe respirable particulate as that small enough to reach the gas exchange region. Differences involve the 50% cut point of respirable dust samplers. The British Medical Research Council originally defined respirable dust samplers as having a 50% cut point of 5 microns. In the U.S., OSHA and MSHA define respirable dust samplers as having a 50% cut point of 3.5 microns. This definition is actually quite out of date based on the current science, and OSHA is trying to update this definition in their 2013 notice of proposed rulemaking on respirable crystalline silica. In an attempt to reach global consensus in the occupational hygiene community, a compromise definition for respirable dust samplers was developed in the 1990s, specifying a 50% cut point of 4 microns. At this time, most global occupational hygiene organizations and standard-setting bodies have adopted this specification, and U.S. OSHA is attempting to do the same. SKC has several cyclones that meet the new global consensus definition of respirable dust samplers at designated flow rates. The SKC aluminum cyclone achieves the 4 micron cut point at 2.5 liters per minute. The SKC GS3 cyclone achieves the 50% cut point of 4 micron at 2.75 liters per minute. The GS1 cyclone has a designated flow rate of 2 liters a minute, and the SKC plastic cyclone, manufactured by SKC Limited in the UK, has a designated flow rate of 2.2 liters a minute with 4 micron cut point. For those that want to achieve the 3.5 micron cut point still specified by OSHA or MSHA, contact SKC and we can provide alternative flow rates. Like for thoracic particulate, SKC has developed a new impaction-based sampler for respirable dust called the Parallel Particle Impactor, or PPI. The PPI was designed to improve performance characteristics evidenced with some of our old traditional cyclones. The disposable models of the PPI look and function very much like a traditional 37mm cassette. But the inlet piece comes preloaded with size-selective impactor plates that scrub out non-respirable dust. Note that you are not concerned about how much particulate is collected at each of the individual inlets, but only what is collected on the final filter. Single-use disposable PPI models are available for use at 2, 4, or 8 liters a minute. This provides flexibility in pump options and sample duration with various workplace concentration levels. A handy calibration adapter is also available for the disposable PPI. Respirable PPI samplers closely conform to the ISO, CEN, ACGIH, and NIOSH criteria. As such, they meet the requirements specified in the 2013 OSHA proposed rulemaking on respirable crystalline silica. Finally, let's discuss a submicron respirable dust, DPM, diesel particulate matter. This contaminant is quite common in mining operations due to diesel-powered equipment used underground. Specifically, if we look at coal mines, workers may be exposed to DPM along with respirable coal dust. So a sampler was developed by the NIOSH Mining Division to separate these two types of respirable dust based on the simple principle of particle size. Diesel particulates are less than 1 micron, and coal dust is greater than 1 micron. Here you can see a schematic of the DPM filter cassette with GS1 cyclone. The GS1 cyclone meets the requirements of U.S. MSHA regulation. Note, however, that the cyclone serves only as a pre-scrubber to ensure the filter's impaction plate is not overloaded. Other cyclones can be used if they meet your agency requirements. The cyclone removes non-respirable particles that may overload the filter. The impactor inside the filter cassette removes respirable particles bigger than 1 micron. And the heat-treated quartz filter collects particles less than 1 micron for analysis of total or elemental carbon following NIOSH method 50/40. We have just reviewed air sampling of particulates followed by laboratory analysis. In many operations, however, occupational hygienists need to determine dust exposure levels on site. For this purpose, SKC offers direct reading dust monitors. The HAZDUS-4 is an aerosol photometer which uses the principle of light scattering for exposure measurements. The LCD displays TWA, STEL, min, and max levels in milligrams per cubic meter. There is also an internal pump to collect a filter sample if needed. An ION sampler for inhalable dust or a GS cyclone for respirable dust can be added to the inlet for size selection. The HAZDUS-4 is factory calibrated in an aerosol chamber, but a calibration standard is also available so users can do frequent cal checks. The calibration standard is simply a metal adapter that causes a known value, a K value, to appear on the LCD. The instrument will have a K value assigned by the factory when it is new. The K value should not deviate more than 10% during subsequent checks. HAZDUS monitors are factory calibrated using Arizona road dust. For higher accuracy, users can collect concurrent samples using filter cassettes, compare lab results to LCD readings, and generate a correction factor for the particulate dust under study. Thank you for taking the time to complete this training module. If you have further technical questions, email me at skctech@skcinc.com or call your local SKC office.